Hi students, so welcome to Physics to Learn here. So in last previous classes we have been discussed regarding the gravitation. So in this class which we are going to discuss one of the most important concept for theory part, so which they can ask either for 3 marks or 5 marks. So in last class we have been proved a relation between small g and capital G. So how the g can be varies. So acceleration due to gravity can be varies because of height, depth and rotation of earth. So in this class we are going to discuss mainly regarding the two cases how small g acceleration due to gravity of earth can varies with the help of height and with the help of depth. So before going to the concept, please subscribe my channel, like it and then share to your friends. So acceleration due to gravity below and above the surface of the earth. So how we can explain this? So which we are going to discuss the concept. So acceleration due to gravity already which we have been discussed. So the same thing now which I am going to explain. Consider the earth. This will be the gravitational field. Regarding this gravitational field in detail which we are going to discuss. If object of mass m is left in a gravitational field of the earth, so there will be a force of attraction, so which we know very well that force is F. From Newton's second law, so you have been studied that F is equals to ma, A is equals to F by m. So this is called acceleration due to gravity, so which we can tell that. So for our purpose, which it has been represented by small g. So and then whenever we are having two bodies of masses, so that gravitational force is nothing but capital G into capital M into small m by r square. So which we can substitute that. By substituting that, mm can get cancelled. So small g is equals to capital G into capital M by r square. So this is a simple form which we can tell relation between small g and capital G. In previous class which I have been said how the g can be varies with the help of a depth. Based on that also which we can prove that. So acceleration due to gravity on the surface of the earth value, so which you have been taken it as this g value is nothing but 9.8 meter per second square. So we know already values. Capital G represents universal gravitational constant 6.67 into 10 to the power of minus 11 along with units, and mass of the earth is 6 into 10 to the power of 24 kg, and r represents, so which is nothing but radius of earth. Radius of earth will be 6400 kilometers. In terms of meters we can write it as, so this r value is nothing but 64 into 10 to the power of 5 meters, which we can write. So by substituting all these values, so which we can get it as small g value is equals to 9.8 meter per second square. So in some cases for calculation purpose we can use it as small g is nearly equals to 10 meter per second square. So if they have been given 9.8 we can use that, or otherwise, so for calculation purpose e.g. we can take it as small g is equals to 9.8 as exact value or 10 meter per second square, which we can be used. So this value is a constant, but g value it can varies depending upon height and then depth. So how it is going to change, which we can say this. So acceleration due to gravity at a height from the surface of the earth. So this derivation part is in this it will be having calculation part. Please try to understand. So if you are unable to watch, if you are unable to understand that, please try to watch it twice. So earth is denoted by mass m. So an object which I am considering it as m at a height h above the surface of the earth. That will be the h. But while taking from where we should have to take it means that which we should have to take it from center of the earth, which you should have to take it. So that means this distance, radius of earth is, I can take it as re from center of the earth. So then what is the total height, that which I can take it as re plus h. As object inside the gravitational field, here the gravitational field is nothing but a force of attraction. If it is out of means that earth, it cannot be attracts. So inside the atmosphere in simple form, which we can tell it. So there is a gravitational force acting towards the center of the earth. So the gravitational force is same as weight acting downwards. So weight is nothing but, so gravitational force which we can be used. So with the help of this, if gh is the acceleration due to gravity at a height, then weight is nothing but m into gh, which I can be used. So the gravitational force, for its formula we know, capital F is equals to small g into m1 m2 by r square. So r value is nothing but h plus r. So where capital R represents radius of earth. With the help of that, mm can get cancelled. So which we can write it as, so which is nothing but gh is equals to capital G into capital M by r plus h whole square. So this is what acceleration due to gravity at certain height gh. But I need in terms of small g. So how we can represent that? So on the surface of the earth, so just now we have been proved same consideration can be take. An object of mass m on the surface of the earth, as object is inside the gravitational field, there is a gravitational force acting towards the center of the earth. So which we can write it as, the gravitational force is same as that of weight acting downwards. So with the help of that, which I can write it as same formula as weight is equals to mg. By substituting that, we can write it as, so capital G into capital M into small m by r square. So with the help of this, on the surface of the earth, already have been proved small g is equals to capital G into capital M by r square. So now I know on the surface of the earth, now I know at certain height. So between this, the relation, so which I can give it as which I can obtain it as like this. So for this, so expression for small g at small height h in terms of g on the surface of the earth, so which I can be obtained. With this, so what we can conclude that, so just now we have been proved g value and then gh value. With the help of this, so which we can give a relation between them as, so which is nothing but gh is equals to small g into r by r plus h whole square. So by taking r square as a common, r, so which I have been sent it downwards, r plus h by r whole square, so which I have been taken. By making this modification, I can get it as 1 plus h by r whole square. So this, it has been moved upwards, I can get it as g into 1 plus h by r whole to the power of minus 2. So this will be in the form of binomial theorem, so that which is nothing but 1 plus x whole to the power of n. So using binomial theorem, 1 plus x whole to the power of n is nothing but 1 plus nx. So by using that, so finally I can get it as the value as g is equals to 1 minus 2h by r plus h by r whole square and so on. If h by r is very small, which we can neglect this term as, which is nothing but 1 plus h by r square also, which we can neglect. So if you have been neglected this, so finally we can get the answer as, so which is nothing but, so gh is equals to, which is equals to, so capital G into 1 minus 2h by r, so which we can get. So this is the expression, for small g at a small height in terms of g on the surface of the earth, which we can be explained. So this formula, when we are going to use at small heights which we can be used. So otherwise, so GH is equals to, so we can use the expression as this expression also we can be used. So GH, which is equals to G into R by R plus H whole square. If height is very large, under that condition, so we can use this. If it is very small, so we can use it as GH is equals to G into 1 minus 2H. So from the above equation, it's concluded that the value of G decreases with increase of height by a factor 1 minus 2H by R. So if H value is increasing, G value also goes on decreases. At certain particular point, acceleration due to gravity of earth will be 0, then the body which it can escapes. So further one, so which is nothing but expression for G at a height in terms of G on the surface. So this already we have been proved. GH is equals to capital G into capital M by R plus H whole square. So on the surface of the earth, so which you can write it as like this. By substituting this, Gm is equals to G into R square, so which I can substitute it as GH is equals to G into R square by, which is nothing but R plus H whole square. So the same one, so which I have been said, so in this manner which we can be proved it. So this is expression for GH at a height in terms of G on the surface. So based on that, two cases. One is if it is very near to the surface of the earth, GH is equals to G into 1 minus 2H by R. If height is far away, so under that condition we can use it as GH is equals to G into R by R plus H whole square, so which we can be used. Next, effect of depth on acceleration due to gravity. So this before going to discuss how G value can vary, we have been said, if you have been understood that concept, it will be very easy for you to understand this. So if this is a earth which I have been taken, it has from O to A, that radius is R, but if I have been taken a body towards a point B, under that condition to a depth D, that radius will be R minus D. So with the help of this, so what we can prove, just we can check it once. So we know, so mass of the earth is m is equals to 4 by 3 pi r cube into rho. So by substituting that, I can get it as capital G into 4 by 3 pi r cube into rho. By cancelling that, so I can get it as, so 4 by 3 pi capital G r into rho. So now if you have been seen, so whenever depth is there, under that condition it is directly proportional to r. If r value changes, then G value will changes. That means here r is decreasing, so GD value also which is going to decrease. So with the help of that, so what we can tell it. So G dash, that at a depth D, which I am taking it as, so G m dash into R minus D whole square. So I know here, which is nothing but on the surface of the earth, so this is the value, and inside the depth, that G dash is equals to, this is the value. So under m dash value, I can write it as, so which is nothing but, so 4 by 3 pi r minus d whole cube into rho. That means with this two equations, now which we are going to use it. So by substituting this, so G dash value I can get it as like this. So with this I can get it as by using these two equations. So now I know capital G value in terms of density and then G dash in terms of density. I should have to find out the value of g dash, so which I can find out. So equation 2 divided by equation 1, so which I can do it, and then we can obtain the relation. So this we have been proved just now. So with the help of this equation 2 divided by equation 1, so which I can get it as 4 by 3 pi into g into r minus d into rho by 4 by 3 g into r into rho. In all this, so which we can make it get cancelled, 4 by 3 pi capital G into rho. So finally, if you have been observed, so this which is going to be get cancelled. So this is going to be cancelled and this is going to be cancelled. In the same way, rho will going to be cancelled, and then rho. Finally, we can get it as g dash by g is nothing but r minus d by r. So with the help of this, g dash is equals to, I can write it as capital G into 1 minus d by r. So with this also we can conclude that when our object is moving inside the earth, so that acceleration due to gravity is going to decrease by a factor of g into 1 minus d by r. So g value will be maximum on the surface of the earth. If it is moving upwards, g value is decreasing. If object is moving into the earth, also it's going to be decreased. The value of acceleration due to gravity decreases with depth. So just one MCQ, just you can see it. Acceleration due to gravity at a depth d from the surface of the earth is, so which you have been proved just now, so which is nothing but g dash is equals to g into 1 minus d by r. So which you have been explained. So as we go below the surface of the earth, the value of acceleration due to gravity, so which will be what it will be happen, so which is nothing but it will be decreases. Why we have been proved, so which is nothing but g dash is equals to g into 1 minus d by r. I hope that it has been useful for you. So thank you for watching. Have a nice day.